Astrotometry log. It is July 21st, 2012. And I want to discuss a contemporary problem right now, a current event, the drought that the United States is experiencing, in regard to what I know about the nature of the solar cycle and how the extreme heat and the drought is related. And rather than take you along my hike in video, I'm going to go ahead and make this just audio and hope to put some visual aids over the top of this as we go along. Enjoy. And this is uphill from this point, so if it sounds like I'm winded, it's because I'm walking uphill while I'm giving you this lecture. I haven't been able to imagine many aspects of scientific study, scientific disciplines that aren't going to be affected by the discoveries that I've made with astrotometry. Our present model for understanding climate with respect to moisture, clouds, cloud formation, all of it will have to be rewritten, because our present understanding assumes certain things about the nature of matter that are going to be disproven in the near future. And this is going to cause an incredible upheaval in the climatology schools. The thing that is the most elusive is the nature of the conservation of volume. We assume with our current model that the volume of water on the earth is conserved. We assume that it has to be accounted for in a particular way with evaporation and condensation, and that the formation of clouds is strictly dependent on evaporation, condensation nuclei, and that these things determine the rainfall. And this model is wrong. And the more subtle reality is that what rains down on the earth in the form of water is a lot of times bubbling into particular places in the upper atmosphere from energetic disturbances. The materialization and rematerialization of things, of physical matter, as it moves through time, happens from distant energetic connections that are physical, not just theoretical, not just probabilistic, as they are in quantum mechanics. And as in astrotometry, the Earth, the material on the Earth, is constantly moving on the subatomic level in the upward direction, and gravity being the reaction to that movement. In other words, the force of gravity in astrotometry is understood to be a reaction against an upward movement that happens not on the macrocosmic scale, but on the microcosmic scale. In other words, within what we perceive to be the light that's coming from the stars and the sun, there is a movement in that upward direction. And so this sorts out, if you follow those pathways, the actual shape of the astrotome. But that continuity is disrupted by solar physical phenomenon. And normally you would think of the sun as evaporating the water that's on the surface, and that evaporation taking the form of clouds and rain as condensation nuclei are available for those processes. But in reality, the amount of rain, the amount of water that falls out of some of these storms simply can't be accounted for by evaporation. And if you look at the very, very hot water that we've seen in the oceans over the past several years, why aren't there huge storms forming? It certainly isn't for a lack of condensation nuclei. And climatologists will tell you, oh, well, there's this low pressure system that is necessary to get one of these things started. And this is kind of like the force of gravity that has no known explanation in the modern school, in the modern canon. And this is a rather sad affair. The low pressure system, I have already demonstrated, is associated with a coronal mass ejection from the sun. And paradoxically, it doesn't seem to matter from which direction that coronal mass ejects from the sun, because within 2 days, if it's a large enough mass ejection, there will be recordable storm activity on the Earth associated with that event. And so there is this movement that's happening not on the normal Newtonian level, not on the physical, mechanical level, but on the underlying energetic matter-energy continuum level. What we're seeing right now is very interesting. It's very different than the last solar cycle. We have a lot of solar activity, but not a lot of large coronal mass ejections. And so the stirring that usually happens on the energetic level is not happening. And so normally you would say that the amount of water is constant, and concerned about the ocean levels rising because of the glaciers melting. And as I've said in other videos, this concern is misguided. It miscalculates the true nature of rainfall, miscalculates the true nature of storms as it relates to solar activity. So the prognosis for the future, for the next 2 years, if the solar activity continues in its present state, is fairly dire. The solar activity has been very high, but this stirring activity, this watering activity that the Earth gets from the coronal mass ejections isn't present. And to compound this problem, the Earth's atmosphere is a lot lower than it normally is. And this is because of the extended weakness in the solar activity. And there were some scientists that were very concerned that the distance between the ground and outer space was shrinking, that the atmosphere was disappearing, and they couldn't account for it. And in astrotometry, this is fairly simple, because the air on the Earth is replenished in the same way that the water is replenished. And so when we went through that very weak period of solar activity, it was associated with an atmospheric shrinking that persists to this day. Because of the depth of the minimum, the atmosphere still hasn't recovered. And since the activity has been high, but the emissions have been low, these factors are now acting as a sort of opening, and so there isn't as much atmosphere to protect the Earth from the sun and cosmic energy. And so the ground is potentially vulnerable, the Earth is potentially vulnerable to rapid heating because of this thinner atmosphere. Now, from my perspective, the more important concern is whether or not we're going to see the emissions pick back up to the level that they were prior to the beginning of the solar cycle. So in other words, we have this activity, but the emissions, the apparent mass of the ejecta that we're seeing from the sun, the strength of the solar ejections is decreasing. And the size of the spots, if you look at the size of the spots in this solar cycle, the size of the spots aren't nearly as large as they were towards the peak of the last solar cycle. And this is probably related to the fact that the ejections are smaller, not as massive. And there's not as much water that is being put back into the system, not as much air that is being put back into the system. And in astrotometry, it's understood that the process of life on Earth, the natural entropy that life organizes itself into, actually consumes the air and the water. And so there's this process, this chemical process, whereby the nitrogen and the oxygen and the water are bound up into more solid features. So most people know that the human body is mostly water. Most people maybe don't realize that hydrocarbons are also mostly water. They're carbon and water. And this mass, this biomass on the Earth is increasing. And therefore, the water has to be replenished from this higher source. Many of you will remember, before the solar cycle started, I was very concerned that we would actually be seeing global cooling and that we could see a mini ice age. Well, clearly that's not the case. The solar cycle started back up. But the problem is that it was too low for too long, and now our shields are down. And so if you consider three-dimensionally, and in astrotometry this is not really known to be the case, but if you model it three-dimensionally, since we have 3D modeling capability. Think about the space outside the Earth not being empty, but having a certain energetic density. This density decides, in a sense, the permeability of that space to these solar ejecta phenomenon, these energetic forms that are responsible for stirring on the subatomic level and pouring this energy into our atmosphere in the form of water and air from these other time spaces. And so this ejecta phenomenon is an important part of the balance. One of the associated phenomenon of this out of balance relationship is something that NASA is struggling to understand, called the Noctilucent Cloud. There are these very, very high clouds. They're so high that once the sun goes down, the light from the cloud reflects back down on the Earth. And so they appear to glow because they're reflecting light from the sun. And most atmospheric scientists know that there's really technically not a way for water vapor to get up that high. We don't usually see clouds up there. And there's this buffer space between the atmospheric layers where there are never seen clouds. And so, where do these clouds go? Where did they come from? In astrotometry, it's understood that the density of the energetic field, the energetic form that surrounds the Earth, in a sense determines the permeability of the forms, the energetic forms that are responsible for the formation of clouds. So what we're seeing is a sort of abortion of cloud formation that is happening at another energetic level. And in astrotometry, it's understood that these sorts of material continuity manifestations, these sort of changes in the permeability and the continuum of physical matter happen underground in the form of the earthquake, happen on the ground in the form of luminous activity a lot of times, above in the form of clouds. It goes all the way up. Climatologists could try to talk their way out of this if they did the measurement of the volume of the water that these big storms produce. They wouldn't be able to deny the reality based on their own volumetric conservation system. But I don't know when that's going to happen. I'm not going to hold my breath. When I studied weather in college, we learned that these low pressure systems are often associated with the formation of a cloud because the air beneath the cloud doesn't receive the same amount of solar energy as the air surrounding it. And so there is this energetic differential. And the cloud, you would think, would absorb this energy and fall to the earth. But it doesn't. It defies gravity for some reason that is abstracted in the meteorological world as an electrical charge. And so it's believed that there's a charge differential that keeps this mass from being affected by gravity. But in astrotometry, since gravity is understood to be the consequence of the normal continuum of matter through hypertime, these hypertime disturbances are associated with clouds and fog and similar sorts of atmospheric phenomena. The electric potential, the discharge potentials between the Earth and the sky during some of these events are the result of accumulation past a threshold. If you're a climatologist and you can't wrap your head around astrotometric translation, you can't understand the concept that matter and energy are carried in the same waveform that has disturbances in it that change the manifestation of physical matter through time, and that clouds are a symptom of that. If you can't understand that, then take a look at quantum electrodynamics and consider the quantum foam model, which I don't recommend, but it's an alternative way to understand this same truth. So if you can imagine that there is this underlying wave, this underlying movement in our time-space, in our movement through time, even when you're standing still, completely still apparently, there is this flow that is not always perceptible from any physical clue, because it's happening on the atomic scale, because it's happening on the level of the atom. And this ebb and flow can actually displace physical atoms in time and space. These disturbances that we see manifesting as the formation of clouds exist in the carrier, in the wave that carries the matter through time. And these disturbances are more properly understood to be what is evaporating the water, moving the air, turning the seas, changing the clear sky into a cloudy sky, etc., and so on and so forth. And these disturbances can't be accounted for by the static understanding of the relationship between the Earth and the sky. So there have been a lot of concerns about the drought and the potential for it to continue. And I think that these concerns are very well justified and should be taken very seriously, especially in the case that the solar activity continues in its present form.